Okay, so today we have a power supply board out of a 75-inch Samsung, and the model of the TV is a UN75NU6080FXZA. Alright, it's an LED TV, and this board is, and whenever you see that BN number, that is the exact board number. So it's actually a BN44-00874C. Alright, problem with this board is that it is dead. So the TV is totally dead. There is no light. There's no standby light on the bottom of the TV. Nothing's totally dead, as if the TV is unplugged. If you look on a switch mode power supply, you're going to see a line that is separating the hot side from the cold side. Okay, so as you can see on this board, we have our AC input right here. This is where the plug goes for, plug into the wall. Okay, right here, plug for the power cord for the TV, plugs right into there. And as you can see, everything in here is the hot side. Okay, and it should say on there, as you can see right there, it does say HOT, hot. All right, and this is the cold side, and that is marked right there. Okay, cold. All right, the hot side, be very careful when you're testing voltages, because you can get a serious shock. All right, and you can do some serious damage to the board if you cross some leads up or whatever. So basically run down how this works. All right, so our power is coming in, AC power is coming in, it's going through the fuse. You're going to have a fuse by where the AC power comes in. You're going to have a AC filter or EMFI filter to filter out some of the unwanted noise in the AC signal. Then it's going to be rectified by these diodes into DC. Now this is how it works on any switch mode power supply. Okay, and then this uses a power factor correction circuit, and basically what that does is it takes the DC voltage, all right, and kind of aligns it up with the AC, so that it is not wasting unwanted power or energy. All right, so it's just like a putting it in phase, putting the DC in phase with the AC that's coming in. All right, if you can go on YouTube and learn more about that, but it's just basically what it's doing is just conserving power and energy. Okay, with the DC voltage. So basically, we're going to come in, we're going to go through a power factor correction circuit after the AC voltage is being converted to DC. It goes to a power factor correction circuit, which mainly consists of transformer. Okay, in this case we have two. All right, MosFets, we have two, and also a diode. Okay, from there is going to go through the DC voltage, which is going to be approximately 300. It's going to take the 160 volts that is DC that normally converts the AC into, and is going to actually boost it up. This is also known as a voltage booster. Also, it's going to convert it up to about 380 volts DC because of the power factor correction circuit. Now, a lot of switch mode power supplies do not use power factor correction, so you're going to have DC voltage of about 160 volts across these capacitors. In this case, once the power factor correction circuit is activated, you're going to have about 380 volts across these capacitors. Okay, then what it's going to do is these MOSFETs over here are going to take that, whatever it is, 160 or 380 volts DC, and going to drive the primary windings of this transformer. And as you can see, the secondary windings are on the cold side, okay, which is all over here, and that voltage is going to be rectified by diodes, okay, which are these here, and then converted to DC, a rectified DC voltage through capacitors, and this thus going to the boards. Okay, And pretty much that's it. This is for the LEDs right here. See, now these are MosFets over here on this side. Okay, and these are for the LED circuit to light up the LEDs. And this over here is to produce your voltages going through this plug and to this plug going to the main board. All right, and basically that's also a way of conserving energy by isolating the hot side and the cold side via these transformers. Okay, and that's also to keep the power supply from getting entirely damaged. So if something was a short over here on the secondary side, it cannot get over here because it is totally isolated. Because remember, the transformers, we have a winding here on this side and a winding here on that side. So, and they're not connected. Okay, they're just using a magnetic field. Okay, so the hot and the cold side are not electronically connected. All right, that's why they have that line there. Okay, and you have to use different grounds. All right, if you're testing voltages on the hot side or resistance or whatever versus the cold side. Cold side, you can use anything ground over here, or just use the metal chassis on a TV, for instance. On the hot side, ground your negative lead or black lead, whether testing voltage or resistance on the negative side of the filter capacitors, okay? If you're testing anything on hot ground. Okay, so start from the beginning. Like I said, the problem with this TV is that the TV was totally dead. So the first thing I'm going to check is my AC fuse, all right? And I'm just going to go ahead and put it on the beat mode. Here is our fuse here, okay? And as you can see, it is open. All right. So anytime that you have an open fuse on any device, any power supply, or whatever, do not just throw another fuse in there, and please do not put aluminum foil across there because you're going to do some damage. All right, so what I actually did while I was in the customer's home is I actually jumped across the fuse with another fuse. You know, you can use a pico fuse too, which is make sure that the voltage, the current, what is it, voltage? Yeah, make sure the current rating is lower. And I just used this and jumped across it and it blew out again. Okay, so probably what you want to do is you want to check when you have a blown fuse, especially on a power supply board for a TV, is you want to start checking these MosFets, okay? So these MosFets are actually driving these transformers, all right, okay? And that is what is actually increasing the voltage from the regular 160 volts DC to 380. And the diode is helping to rectify that. This is the diode, these are the MosFets. And I can just tell that by looking at it, right? Because I know how it works. And these MosFets have to be driven, okay, by a driver IC, which is located. Okay, so these are the MosFets here, right? And the driver IC is the closest one to it that is there, obviously. All right, now these MosFets here are driving these transformers, okay, which is what they call the chopper circuit, I believe. And these MosFets are being driven by, obviously, these are the MosFets here, right? By this IC right here. That is the driver IC for those MosFets, okay? Pretty simple, right? Since I know I have a short, I'm going to start checking these MosFets, okay? I actually have 4 that I see offhand, okay? A lot of boards may use surface mount MosFets, like on a smaller TV, and you will see some at the bottom. But here, I really don't see anything but a couple of driver ICs right there, and some diodes. These are all part of the power factor correction circuit, I believe. These diodes up under here. And so, I'm actually gonna pull this stuff up. But what I did notice is that right here, we have looks to be a burnt capacitor. After I pulled some of the silicone stuff off, this capacitor is actually burned. And maybe you can see it on the side. Yeah, it's actually burned and left a little mark on the board. Okay, so it's always good to use your vision, your sense of vision, first before anything. So I'm going to flip it over and I'm going to check those MosFets. Right here, these are the two MosFets for the power factor correction circuit, obviously. And right next to it is this diode where we sent that burnt capacitor at. So my meter's in beep mode. And I did put some like a conformal coating off of the bottom of the board between those MosFets. And over here, these are the two MosFets that are driving, or I use for what they call a chopper circuit, which are driving the isolation transformers, okay? All right, these two MosFets right here, which I have kind of like circled in red. All right, so my meter's in beep mode. No short there. No short on that MosFet that I can see. Just to make sure I'm getting, put my meter in diode mode, just make sure I'm getting a reading, period. Okay. Because some of that conformal coating is still on top. Alright, so yeah, so no short on that one. I'm gonna go over here. To the two MosFets used to drive these transformers in the power factor correction circuit, used to amplify that 160 volts to 380 volts. That's primarily the best way to remember what it's used for, which it is. All right, and to get the most bang for the buck as far as your energy consumption or power consumption, that's what they call it, power factor correction. All right, so anyway, I'm going to go back to beep. And as you can see, I have a short there. That is shorted, okay? This MosFet is also shorted. Now getting a short between the gate and the drain. Between the source and the drain, I have a short. And I'm also going to check this diode. Okay, so both of these should be shorted. That's a diode. These are both the anode and make sure I get a reading. Put it in diode mode. .4 volt voltage drop that way, and infinite the other way. Okay, 0.4 that way, and infinite that way. Now the capacitor right next to it doesn't seem to be shorted, but it was definitely burned. Okay, so these MosFets were good for the switching circuit, all right, for the switching mode transformers, and these MosFets are reading short. Diode is good, but we still have that burnt capacitor next to it. All right, so I looked online and I did find a kit. All right, so evidently this must be a common problem with this particular TV. Okay, as you see what it comes with. It comes with some capacitors. The smaller one looks like the one that was burned. All right, both of those MosFets and fuse, and also comes with heat sink compound, which is good. All right, so we have both MosFets, and it should say QP801, QP802, A74C, A74D, and A74F, which may or may not be interchangeable as far as the whole board is concerned. But you definitely want to check those plugs to make sure, because it may even look different, but as long as those plugs are the same and they have the same labeling on the plugs for the different boards, it's quite possible you can interchange them, but I will be on the safe side and just get the exact suffix, which is C. Those are 60R190Q. 60R190Q looks like. And if I can get the, and then I like how they gave you those extra capacitors, because what's probably going to happen is you're going to be pulling that silicone stuff up from around the transistor before you remove it, and you might end up breaking one of those capacitors. Also, because those seem fine, even the burnt one seems fine. It's not shorted or anything. It doesn't matter if they're open, you're not going to do any damage, you know, but yeah, they're not shorted, so that's the main thing. So anyway, let's go ahead and pull those out of the circuit so we can replace them with our new ones. Soldering iron for those type of MosFets. Yeah, I used big head. Yeah, I got a big head. Okay, so let's go ahead and proceed to remove those MosFets, and I'm going to replace that capacitor too. I think I want to mention, when you solder or unsoldering, whatever, is if you don't have a vacuum for the air, it's good to wear a mask. And also I have my fan. Okay, right there. Okay. Alright, so if you don't have a fume extractor, you can always take precautions, because I'll never forget one time I was in a customer's house soldering, and when I started smelling the solder, I got very faint, like I was about to fall out. So I don't know what type of solder I was using or what, but always take precautions as far as those fumes, because there is lead, maybe lead in the solder, that try to scrape as much as conformal coat off as possible. Another thing I want to point out when replacing MosFets is and the power supply, is always check the gate pin and make sure there are no blown components on the gate pin, which is the drive circuit. Alright, make sure there's no blown or open resistors. Since I'm facing this way, that's going to pin to the right. Right here, and I don't see anything blown. Okay. As far as my eyes can see, it looks good. These components look good here. Usually a 10 ohm resistor or somewhere around that area, that's usually coming from the drive IC, which obviously is located right there. Okay. Voila. And also want to replace the capacitor, which is this one here, so it'll be to the right of this diode. And as you can see, that is shot. Alright. And it's obviously one of the smaller capacitors. I'm sorry, this is silicone. You can always just use a knife to start out with. Just being very careful. R190Q. I'm going to put some heat sink compound on the back. That's fine there. I'm going to place it. I'll run one of the pins out, place it in the hole there, and so get it in there. We're just going to bend it back. Now just a little bit more. Let's see here. So I can align it up. capacitor. Excess off. And don't want to forget about our fuse right here. You see a little symbol, a little fuse symbol right there. That's the fuse here and here where the arrows are. So let's get rid of that right fast. Replace that. That should come right out. There we go. And we may be all set. Seems good. Let me go back to the FETs. Hope almost scared me there. Okay, so the first thing I'm going to do is just go ahead and plug it in right fast and make sure the fuse didn't blow again. And then if it didn't, I'm going to plug it back in and recheck for my standby voltage on the secondary side. That lets me know that everything on here should be working. All right, minus the backlight circuit, which I doubt we have a problem with. Making sure there are no metal shavings or leads up under the board. Looks fine. Okay. Heard it click. It's a good sign. Do we have a relay right here? Heard it unclick. Heard it click. So most likely the fuse is good. Still. All right. Now let's check for our standby voltage, which should be somewhere over here. Okay, and one of these pins is marked right there. And as you can see, it is marked 7.5 and standby. And when it says powered on, that particular jumper wire that it's pointing to should be approximately 12 volts or 11.8 volts. Where am I at? Yeah, right here. It's pointing to this one right there. Okay. I'm going to put a little clip right here. I'm going to go to the bottom. That should be safe. There's nothing else around it. Okay, let me plug it in, and watch my meter. That should change at this pin right here. Here we go. It's actually in the power on mode until you plug the main board, and we have 12.9 volts, which is probably close enough. All right, and it's probably coming from one of these diodes here. Let's see. I'm sorry, that is actually for the LED circuit. Let me go over here to these diodes right here. Go to the cathode. We go 12.9, 12.9. 12.9, and these here are 303. So these here are the start for the LED circuit. Okay, right here. All right. So it looks like, guys, that we are done. What's this here? 12.9 also. Okay. Alright guys, thanks for watching. Make sure that you do subscribe to my channel. Give me a thumbs up if you like the video. And until then, I will see you guys in the next one. Big Dog out.